Okay, so we all know how helicopters work, like the basics.
Right.
But today, we're going to go deeper.
Yeah.
We're taking a look at a patent filed by Igor Sikorsky
Okay.
back in 1940,
Wow.
before helicopters were really a thing.
Like way before they were everywhere.
Exactly.
So this is like early helicopter stuff.
Yeah, imagine trying to describe a helicopter
Uh-huh.
to someone who had never even seen a plane.
Right.
That's kind of the forward thinking we're dealing with here.
That's amazing. What's so fascinating about this patent
Yeah.
is it's not just like a rough sketch or an idea.
Yeah.
It's like incredibly detailed.
Really?
Oh, yeah, covering everything from the rotor systems and engine placement
Uh-huh.
to the control mechanisms.
Wow.
And even the tail design.
It's like he had a crystal ball.
It really is. Like he was
Ah.
looking into the future of helicopters.
So let's dive into the rotor system.
Okay.
What makes his vision unique?
Well, he starts with a 3-bladed main rotor, which, as you know, is pretty common.
Right. We see that a lot.
But it's how those blades are connected and how they move
Yeah.
that really sets it apart.
Okay.
So each blade is attached to the hub
Uh-huh.
with a universal joint.
Then that allows...
So this allows for both flapping, that up and down movement,
Okay.
and something called feathering.
Feathering.
Yeah.
Sounds delicate.
It is, in a way. Think of a bird
Okay.
adjusting its wings to control its flight.
Uh-huh.
Feathering is essentially changing the pitch angle of the blades.
Oh, I see.
And it's crucial for controlling the helicopter's movement.
Makes sense.
Sikorsky also uses flexible connections
Okay.
to make sure the blades rotate with the hub while still allowing for this flapping and feathering.
So it's a system designed for both strength and flexibility.
Exactly.
Okay, so these blades are more than just like rigid pieces attached to a spinning hub.
Right.
But how does the pilot actually control this intricate system?
Well, that's where Sikorsky's ingenuity really shines.
Okay.
He describes a system of links and levers
Uh-huh.
connected to each blade,
Okay.
allowing the pilot to adjust the pitch.
I see.
Imagine like a series of rods and cables,
Uh-huh.
all working together
Yeah.
to translate the pilot's movements
Okay.
into adjustments of the blade's angle.
So when the pilot wants to move forward, they push the control stick forward,
Right.
and through this system of links and levers,
Yeah.
it changes the pitch of the blades,
Exactly.
causing the helicopter to tilt and move in that direction.
It's all about manipulating airflow over the blades
Okay.
to achieve that controlled flight.
And this is 1940, right?
Yeah.
So he was already thinking about automation.
It's pretty mind-blowing for the time.
Wait, automation in 1940?
I know, right? Like decades before computers were even a thing.
That's incredible.
So think about the delicate balance
Okay.
involved in helicopter flight.
Yeah?
You've got engine power, blade pitch, and the weight of the aircraft.
Makes sense.
To keep things stable,
Yeah.
you need to constantly adjust these factors.
Right, they're all connected.
Exactly. And Sikorsky understood this,
Uh-huh.
and he came up with this system
Okay.
that would automatically adjust the engine power
Okay.
in response to changes in the blade pitch.
So if the pilot increases the pitch of the blades to gain altitude,
Right.
the engine power would automatically increase to compensate.
Precisely. And vice versa.
So if the pitch decreases, the engine power adjusts accordingly.
Exactly.
Ah.
And this was a remarkable concept for the time
Yeah, I can imagine.
because it helped prevent engine stalls or overspeed,
Oh.
which were big concerns in early helicopter designs.
That's a level of foresight I wouldn't expect from back then.
It's really incredible.
It's like he was anticipating the challenges of helicopter flight
Yeah.
and coming up with solutions before they even became problems.
He was ahead of his time.
But we haven't even talked about the tail rotor yet.
Ah, yes, the tail rotor.
The often overlooked but crucial part.
Right. In Sikorsky's vision,
Yeah.
the tail rotor is more than just a way to counteract the torque
Yeah, to keep it from spinning.
and keep the helicopter from spinning uncontrollably.
Right.
It actually plays a key role in overall stability, too.
So it's pulling double duty,
Exactly.
controlling direction, and helping to keep the helicopter steady in the air.
You got it.
What else did he have in mind for this tail rotor?
Okay, so get this.
Yeah.
He even incorporates something that seems like an early form of autopilot.
What?
Yeah, there's a weather vane
Uh-huh.
connected to the tail rotor,
Okay.
which automatically adjusts the pitch of the blades to compensate for wind.
So imagine a helicopter
Yeah.
that could self-correct for changes in the wind.
Back in 1940.
That's amazing.
It's pretty wild.
But hold on.
Yeah.
We're only scratching the surface.
I know, right?
Remember you mentioned something about an extra auxiliary rotor?
Oh, yeah, that's right.
Okay.
Sikorsky's patent describes not one,
Right.
but two auxiliary rotors,
Whoa.
in addition to the main rotor.
Okay.
We've talked about the tail rotor,
Right.
but there's another one mounted vertically,
Oh, okay.
intersecting the plane of the tail rotor.
Okay, now I'm trying to picture this.
It's a lot, right?
You've got the main rotor on top,
Yep.
the tail rotor at the back,
Uh-huh.
and this other rotor sticking straight up in the air.
Straight up.
Were they all spinning at the same time?
They were, but
How would that even work?
it was ingeniously designed to avoid collisions.
Okay.
I know it might sound chaotic,
It does.
but the timing of the blades was carefully coordinated.
Really?
Oh, yeah, to ensure they never came into contact.
Wow.
And this configuration,
Yeah.
it offers some significant advantages in terms of control and stability.
So what's the purpose of this second auxiliary rotor? It sounds like a lot of extra complexity.
Complexity, yes, but with a very specific purpose.
Okay, what's the purpose?
This vertical rotor primarily assists with pitching the aircraft.
Teaching.
Yeah, tilting it forward or backward.
I see.
Imagine trying to precisely maneuver a helicopter without this.
Oh, so it's like an extra set of controls
Exactly.
for fine-tuning the helicopter's movements.
You got it.
Wouldn't it also contribute to lift, though?
That's a great question.
Yeah.
And one that Sikorsky himself addresses in the patent.
Really?
He suggests that this vertical rotor could potentially contribute to the overall lift of the aircraft,
Oh.
working with the main rotor to lift heavier loads.
So he was envisioning a helicopter that could adjust its lift capacity.
It's like he was looking into the future of heavy lift helicopters.
That's incredible.
Yay.
And all of these groundbreaking ideas.
Yeah.
They're laid out in such detail in this 1940 patent.
It's amazing how detailed it is.
The language he uses might seem technical, but it paints such a vivid picture of how these mechanisms would work together.
I'd love to hear an example.
Okay, yeah, give us a taste.
All right, so in describing how the engine power is transmitted to the rotors, he writes, and I quote,
Okay.
a positive driving connection between the main rotor and the auxiliary rotors,
Okay.
and an automatic one-way driving connection between the engine and the rotors.
It's like a blueprint written in engineering code.
It really is.
I think we need to pause here for a moment and let all this sink in.
I agree, it's a lot to take in.
We'll be back in a moment to delve even deeper into this patent, so don't go anywhere.
It's going to get even more interesting.
Okay, so we were just talking about that second auxiliary rotor,
Right.
the one that's mounted vertically.
Yeah.
Sikorsky seemed to love adding complexity,
He did, but
but it always made the design more elegant and functional.
he had a way of doing that.
Right. It's a great example of how he approached engineering,
Instead of shying away from complexity, he
Yeah.
kind of embraced it. Yeah.
using it to make things better.
To achieve greater control and stability.
Exactly. And remember,
This is 1940.
can you imagine the calculations?
Right.
He must have been doing all this without computers.
That's mind-boggling.
Seriously.
But speaking of complexity,
Yeah?
we haven't talked about how he was going to control all these systems.
Right.
You've got the main rotors, two auxiliary rotors, the engine.
It's a lot.
It's a lot to manage.
You're right.
So how did he envision that?
Well, he gets into that in the patent.
Really?
He talks about the specifics.
Of the controls.
Yeah, describing how the pilot's actions would translate to the rotors and engine.
Okay, so walk me through it.
Okay.
Let's start with the engine.
All right.
How did he imagine the pilot controlling that?
Well, remember that automatic throttle control?
The one that adjusts based on the pitch.
Exactly.
Okay.
Well, he realized that sometimes the pilot would need to override that.
Yeah, that makes sense.
Like in certain situations, you need to be in direct control.
So he put in a manual override,
No.
a lever that would bypass the automatic system.
So the pilot had automatic control when they wanted it,
Right.
but they could also take over if they needed to.
It's like having cruise control in your car, but you can switch it off.
That's a great analogy.
Right.
Okay, what about the other controls?
Sure.
How would the pilot control the pitch of the main rotor?
He describes a system of rods and linkages connected to the control stick.
Oh,
Moving the stick forward or backward would change the pitch.
so that's like the cyclic control stick we see today.
Exactly. It's the precursor to that.
But what about the tail rotor?
For that, he used a system of cables and pulleys. connected to pedals.
Guys, okay.
Pressing the pedals would change the pitch of the tail rotor blades.
So like rudder pedals in an airplane.
Exactly, controlling the yaw.
Which is the rotation around the vertical axis.
That's right.
It's incredible how he thought of everything.
And this was all in 1940.
It really is amazing.
He was laying the groundwork for the control systems we still use today.
It's a testament to his vision.
Absolutely.
But there's one crucial thing we haven't talked about.
What's that?
Landing.
Oh, right.
How did he think about bringing this thing down safely?
Well, landing a helicopter, especially back then, was tough.
Right. They didn't have all the fancy landing gear.
It was basically just skids or wheels.
So a rough landing if you didn't do it right.
Exactly. So he came up with a solution.
Okay, what did he do?
He designed a foot pedal.
Another pedal.
This one would decrease the pitch of the main rotor blades right before touchdown.
So it's like a controlled descent.
Precisely, gently reducing the lift.
Okay.
And to make it even smoother.
Yeah.
This pedal was also linked to the engine throttle.
Oh, so as you reduce the lift, you also reduce the power.
Exactly, preventing the rotor from overspeeding.
That's so smart.
It really is. He was thinking of everything.
Right. It's like he was anticipating every problem.
And designing solutions right into the system.
So this foot pedal was basically the early version of the collective control.
That's right, controlling the overall lift.
But back then, it was a separate pedal.
Imagine that.
Crazy.
And remember that vertical auxiliary rotor?
The one that helps with pitching.
Yes, that one.
We talked about how it could contribute to lift.
Well, he suggests in the patent that it could do even more.
More.
He talks about dynamically adjusting the lift capacity.
So changing how much the helicopter can lift on the fly.
That's the idea.
Wow.
A helicopter that adapts its lifting power based on the weight or maneuver.
That's incredible, like a shape-shifting helicopter.
You got it.
It's like he was thinking about helicopters as adaptable platforms.
For all sorts of tasks.
Not just flying machines.
Exactly. He was way ahead of his time.
His forward thinking is amazing.
It really is.
Okay, but let's talk about the tail rotor design.
Sure.
What was so special about it?
Well, he preferred a single blade design.
Really? I thought most helicopters have two or more.
It seems counterintuitive, but a single blade can be more efficient.
Oh, I see.
Less drag.
Less weight.
Exactly.
So better performance.
Right.
Where did he want to mount it?
On a cantilever structure coming out from the fuselage.
So basically a boom sticking out the back.
Exactly like we see today.
Why that placement?
To keep it clear of the downwash from the main rotor.
Oh, right. All that turbulent air.
Yeah.
The tail rotor needs clean air.
To work properly.
Okay. Anything else clever about the tail rotor?
Oh, one more thing.
What's that?
He said the drive shaft could be hollow.
Hollow? Why?
To put the control rod for the pitch mechanism inside.
Oh, I see.
So it's all tucked away neatly.
Smart. It simplifies everything.
Right.
This whole patent is full of these little aha moments.
I know, right?
He wasn't just making a helicopter that worked.
Yeah.
He was making one that worked well.
Efficient, reliable.
Graceful, even.
He was a true visionary.
He was anticipating problems and coming up with elegant solutions.
And it's all right there in this 1940 patent.
It's incredible.
It makes you wonder what he would think of helicopters today.
Right. How would he react to all the advancements we've made?
That's a great question.
It makes me think.
What do you think?
I bet he would be thrilled.
Yeah.
But I also think he would want to push even further.
He was always innovating.
Exactly. Exploring new frontiers.
It's his legacy.
The spirit of innovation.
Pushing the boundaries of what's possible.
Okay, but before we go too far into the future,
Yeah.
there's one more detail about the engine we should talk about.
Okay. What is it?
How did he handle the engine placement
Right?
to make sure the helicopter was balanced?
He put it beneath the main rotor.
Okay, that makes sense.
But it's more than just convenience.
What do you mean?
It's about balancing the weight.
Oh, because those blades are heavy.
And they create a lot of force,
So the engine counteracts that.
keeping the helicopter from being top-heavy.
Like a seesaw.
Exactly.
You need weight on both sides.
And to make it even better,
Yeah.
he used a belt drive and a one-way clutch.
So the belt drive transfers power.
From the engine to the rotors,
And the one-way clutch.
that lets the rotors spin independently.
Even though they're all connected to the same engine.
Exactly.
That's clever.
Right.
Another example of his attention to detail.
He really understood how all these parts interacted.
Okay, but there's one more thing about the engine.
Okay.
What is it?
He wanted to synchronize the main rotor
Huh?
with the vertical auxiliary rotor.
The second one we talked about.
That's right.
So they would be connected and coordinated.
To make the helicopter even more stable.
Especially during hovering and low-speed flight.
You got it.
Wow, it's like a symphony of spinning parts.
It's all working together perfectly.
It's incredible.
This patent is amazing.
It's not just technical drawings.
It's a glimpse into his mind.
A true pioneer.
Someone who shaped aviation.
We need to just stop and appreciate this.
I agree.
This patent is remarkable.
A true testament to his genius.
But before we wrap up, there's one more thing we haven't talked about.
What's that?
The language he used in the patent.
Oh, right.
We were going to look at his writing style.
It's fascinating.
Okay, what's so special about it?
It's very precise.
Yeah.
But also kind of poetic. I'll give you an example.
Okay.
When talking about the vertical auxiliary rotor, he says the blades are arranged to cooperate with the main lifting rotor.
Cooperate.
Yeah.
That's a nice touch.
Like they're working together.
Not just working together, but cooperating.
Exactly.
Yeah.
Okay, when he talks about the landing system, he says it gently deposits the aircraft upon the ground.
Gently deposits. Wow.
It's almost poetic.
Like a ballet.
He understood the art of flight.
Not just the mechanics.
You got it.
This whole deep dive has been incredible.
I know, right?
We've been given a glimpse into the future.
As envisioned by a true pioneer.
This patent is amazing.
It shows his genius and foresight.
It's clear he was shaping the future of aviation. So we've covered just about everything in the patent.
I think so.
But I still have one big question.
What is it?
So what stood out to you the most in this patent? I mean, there's so much there.
Oh, it's hard to pick just one thing. But I think what gets me is how relevant it still is today. Like all these ideas he had, they're still shaping how we think about helicopters. It's wild.
Like he laid the groundwork.
Exactly. Automatic power, those interconnected controls. He even hints at autopilot stuff.
And this was way back when.
Way back. It shows how deeply he understood flight, you know?
It wasn't just tinkering.
No, he was figuring out the core of it. Lift, drag, control, all without computers or anything.
It's mind-blowing.
Totally. This patent isn't just some old document.
Right.
It's proof of what human ingenuity can do. Visionary thinking, you know?
Absolutely. So what other ideas in this patent haven't been fully explored yet?
That's the question, isn't it? What seeds did he plant that we haven't seen bloom yet?
Like that second auxiliary rotor. We talked about it contributing to lift.
Right.
What if we take that further? Could we have helicopters that change how much they can lift?
Ooh, dynamically adjusting based on the job.
Exactly.
Yeah.
Imagine the possibilities for search and rescue, heavy lifting, all that.
It would be revolutionary. Helicopters would be even more versatile, more adaptable.
This whole deep dive has been eye-opening.
It really has.
Sikorsky wasn't just building machines, he was shaping the whole future of flying.
And that influence is still here. Next time you see a helicopter up there,
Yeah.
remember Sikorsky. His vision made it all possible.
Well said. I think we've covered everything here. Any last thoughts for our listeners out there?
Just this. Keep exploring, keep asking questions, and never lose that awe for the people who came before us. They dreamt big, and look what they achieved. Who knows what amazing ideas are still out there waiting to be discovered.
Beautifully put. Until next time, keep looking up.